Really money. It takes a lot of time. It takes money to do software right. You know, non-functional requirements. It sucks. It costs money. You know, always takes a little bit more resources to do software. So with us, and the biggest thing we do is to make intelligent, informed trade-offs, which is like business speak for what everybody does, right? Minimize opportunity costs. Always make the right decisions for the business. And oh god, I forgot to edit that. Whatever. Replace client with members, and remember that that was something I made internally and forgot to edit correctly. Always make the right decisions, right? At least for me as a security professional, it's not necessarily my job to make that trade-off sometimes. Sometimes I have to go to the owner of that division and be like, hi, here are the risks that you have. Here's how bad it could be. It is going to take you 6 months to fix it. What do you want to do? And they go, oh, okay. Well, no, we're not going to fix that. I'm like, okay, problem solved. Not going to fix it. Okay, done. Or they'll say, well, it takes 6 months to fix, and we're going to sunset this application in a year, so I'm not sure if we want to make that investment. Yeah, that's reasonable. I can deal with that. It's fine. In software security, golden rule, especially if you want to make smart trade-offs, is that early attention pays off, right? We're so used to, and traditionally coming from a network security perspective, we're focused on testing, right? Test something. A piece of software is about to go live. Let's test it first, right? Or a piece of software is already live. Let's test it. A little bit worse. Thing is, that's expensive. And the earlier we pay attention to security in the software development lifecycle, the cheaper it's going to be. Okay? We'll talk about that a little bit more. So what we want to do, and the ideal thing, is to ingrain the security a little bit tighter into the development process. So as people are writing code, they're thinking about security and they're making intelligent decisions as they're writing code. So that, you know, 3 months down the line, they don't have to have a conversation with someone like me about going live with a critical vulnerability or not going live. So those are really not fun conversations to have. So I wanted to talk about another thing. We think about design versus implementation weaknesses. Going a little bit more into how we think about vulnerabilities and different types of problems that software can have. So the biggest thing here to remember is that design weaknesses happen when somebody walks up to a whiteboard and makes a bad decision. Implementation weaknesses happen when somebody sits down at a keyboard and writes a bad line of code. Okay? Those are the differences. Good example of a design problem is using an MD5 hashing algorithm to hash your passwords. Right? How many people don't know why that's a bad thing? Okay. MD5 algorithm, hashing algorithm, it's used to scramble things to make them unrecoverable. Okay? MD5 is broken. It has been for 10 years. You can go into Google and do a reverse search on most MD5 hashes less than maybe 20 or 30 characters and find them. So if you're using an MD5 to hash your passwords, it's kind of like jokingly easy to retrieve the passwords if someone gets access to your database. It's a bad idea. You shouldn't do it. But at some point, somebody went up to a whiteboard and said, hey, let's use MD5 to hash those passwords. I think that's a great idea. No, it's not. It's a terrible idea. Okay? And so like I said earlier, earlier attention pays off better, right? It pays off. It's cheaper if you pay attention early on in the software development lifecycle, because if someone who was there in the whiteboard, in the room when they were doing the whiteboard, and said, hey, whoa, don't use MD5. Use SHA-512, which is the newer NIST approved version, right? Said, hey, use SHA-512. Problem solved. 30 seconds. Done. Nothing has to get fixed. The application's about to go live, and somebody goes, oh man, we did it in MD5. We should have done it in SHA-512. Well, okay, now we have to change the code. We have to do regression testing. We have to make sure everything works. We have to do go back and do things all over again. It takes a little bit more time. Maybe a day, maybe a week, depends on how long your regression tests take. It's kind of a pain. If your thing's already been 2 years, and you hear that, oh, we need to change our hashing algorithm, well, guess what? Now you have to fix the code and do regression testing and notify all of your users, change all of the accounts, have everybody update their passwords, reset everything, and it is, from a PR and organizational perspective, kind of a nightmare. It's a lot more work, right? Early attention pays off. So an implementation weakness. How many people here have heard of cross-site scripting? Awesome, right? Cross-site scripting is an implementation weakness. Somebody sat down at the keyboard while they were writing that web page and said, I am not going to output and encode this thing correctly, right? If we did that at design time, we could have said, hey, let's use mustache and not use 3 brackets, and we won't have any problems with output encoding. Or, hey, let's use this specific framework and enforce that all of the output goes this way, and the problem gets solved. If it's near production, well, maybe we need to go through and do a lot of things, change a lot of code. It's post-production, and you have, I don't know, 1,000 cross-site scripting bugs in your product. Guess what? You need to go back and fix them all, and that sucks. On average, it takes 15 minutes across the industry to fix a single cross-site scripting bug for development time. 15 minutes times 1,000, that's 250 hours of somebody fixing cross-site scripting and not doing new functionality for your clients. Not so fun. So yeah, early attention pays off. It's worth it. So how do we find these things? I talk to development teams all the time, and they're like, so how do you find all this stuff? What process do you use? How do you do it? Well, 2 things to think of: splits. Those of us who have done testing before, we split it between static and dynamic testing. That's one of the splits. You can think of that as code reviews versus penetration testing. That's what some people call it. Penetration testing is kind of a misnomer, but it's close enough for government work. No offense to anybody in the audience. Weaknesses can be found with either method, right? I can find SQL injection through static analysis, and I can find SQL injection through penetration testing. But some things, some vulnerabilities, some classes of weaknesses are a lot easier to identify one way versus the other, right? So penetration testing, I'm opening up a browser, I have a proxy in between, and I'm messing around with that website as much as I can, running the site, right? It's really, really easy for me to say, if user A can access user B's data, that's a bad thing. Okay, that's a pretty easy thing for me to test for if I'm looking at a live running application. Okay, if I'm doing static testing, if I'm doing code review, it's a little bit harder to find. You can check and you can say, well, did you do your aspect-oriented programming right? Did you use your code level access control? Did you do this? Did you do that? It's a little bit harder to check, but it's really, really, really easy to figure out how people are storing passwords in the database, right? Whereas if I'm doing a live test against a running app, unless I completely own that application, I'm not going to know how they're storing passwords in the database, right? And that's not really worth my time. So there's both of them, and most code reviewers do both, or most code reviewers, most people doing testing do both, right? Most people in the breaker side of things that try to find problems, they do both. Second split, automated versus manual testing. Whether I want to use a scanner or I want to use a person with a tool, right? It's very, very similar. Manual testing, me sitting around looking at code, it's very slow. Me wanting to break into an application manually, it's very, very slow. Scanners are a lot faster, but they're not as smart. People smarter than machines, yeah? Smiling, okay. Sorry, it's the boring part of it, isn't it? They can't find certain types of vulnerabilities though. Access control things, unless you're really, really, really good at configuring your IBM Rational App Scan, you're not going to find access control vulnerabilities. Okay? You need a person to find that. Sometimes me, sometimes a QA tester, whatever. You need a person to find those. They're really, 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 really good for finding those 1,000 cross-site scripting vulnerabilities we talked about. They're great for that. That way I don't have to waste my time doing it. Most testers, again, do both. Static and dynamic, manual and automated. Okay? If you're just doing automated testing, that's great. That's good. You're not going to get full coverage there. Okay? You're not going to find everything there is to find. You're not going to find every problem there is with your software. So before we go any farther, that was the high-level stuff. We're going to start going down. Does anybody have any questions for me about this stuff?
Yes. Could you?
Yeah.
Could you retouch on the MD5? The reason why it was obsolete.
Yeah.
So MD5 and cross-site scripting.
Sure. So the questions were, can I elaborate a little bit more on MD5 and on cross-site scripting? So MD5 is a hashing algorithm. It's a one-way algorithm. It's designed to scramble something in such a way that it is going to be unique, but you can't backtrace to what the original input was. Okay? It's really good for determining, I have a file, has the file been changed or not? You know, make an MD5 hash of that file and see if the MD5 hash changed. So if I change one character in a file, that MD5 is going to be radically different. It's also good for storing passwords. If you have a password, you store the password hash in the database and not the password, right? So if I go in and I type my password into a login form, the application backend is going to take that password, it's going to hash it, scramble it all up, and it's going to compare it to the scrambled version that it's storing in the database. And if the two scrambled versions match, then my password matches. Okay? But if the scrambled versions don't match, my passwords don't match. It's a way for a system to compare passwords without actually storing the password itself, which is a bad idea. Okay? Cross-site scripting is a little bit more complicated. I'm going to get actually a lot more into it in the control section. The short version is it is an injection vulnerability that allows an attacker to control JavaScript that's executed on a user's browser. And it is one of the top 3 most prevalent application security vulnerabilities out on the web today. Okay? Does that answer your question?
Yes.
Cool. Anything else?
Is the password transported in plain text over SSL?
Generally, yeah, almost always.
So it's never hashed. Well, I guess it couldn't be hashed.
Generally, it is transport layer security, HTTPS, from the user's browser to the server, right? And then the server hashes it in memory and compares it to the stored value in the database. That's a normal flow for that operation. Okay?
I've heard pass the hash.
That you can do hashing algorithms in the browser. The risk there is that so what you really need to be doing is adding a salt to the hash, and that gets a little bit more complex, which means you have to have the salt in the browser to hash it in the browser and send it on, which then starts to get into this, how can you get the salt before you get the username, and blah, blah, and it goes down a rabbit hole. So that is a fantastic question, and I would be happy to talk to you about it after the presentation. And anybody else who wants to listen in, feel free. Come on by. We good? Cool. All right, so lists. How many people have seen this? OWASP Top 10 2013. A few people. Awesome. Those of you who haven't, this is a list of the top 10 most common web application vulnerabilities on the web in 2013, compiled by OWASP. It is a great list. It's very interesting. It is a great tool for outreach, for letting people know, and to make people more aware of software security issues. But if those developers in the audience, do you want to really learn how to exploit cross-site scripting? No, yeah, nobody cares about this. A lot of trainings talk about these, and that's one of the objections I have when you're teaching developers is I want to teach them this. I want to teach you guys this. This is the OWASP Top 10 Proactive Controls of 2014. This is what you, as developers, can do to make your code safe. If you do these things, all 10 of them, you're going to be safe against the OWASP Top 10 and a whole bunch of other things, right? The thing that Jim Manico says is, top 10 web vulnerabilities. What about number 11, right? How to protect against the next one and one after that. Well, you do these things, okay? You start doing this stuff, you start integrating these patterns into your software, and your stuff you write is going to be a lot safer against the vast majority of web application vulnerabilities that people are aware of today. So, we're going to talk about parameterizing your queries. Number 2, encoding the data you send out of your software. Number 3, validating your inputs. Okay? All right. So, controls. Parameterized queries. There are 2 ways to write SQL queries. And we want to talk down. When you're doing that, you can distinguish the query that you're writing from the data that you're querying, or you could not do that. Which one's better?
Do it.
There you go. Do it. Yes. Number 1. Thank you. those of you who had CS degrees like I do, you go to college and they say, hey, this is how you access the SQL database. You go in and you get the information you need and you add stuff in and then you create a statement and you execute it. What's wrong here? There's actually a lot of control with this code. It's not just the SQL stuff. What's wrong with this? What's bad about this section of code?
The validation.
Yes, not the one I was looking for, but yes.
That's vulnerable for SQL.
Yeah, vulnerable to SQL injection. Okay. What's happening here? Update employees, set name equals something, where ID equals something. You're not telling the database, this is command code, this is data, right? This is distinguishing the query from the data. This is what it looks like in Java for those of you who like Java. Do the same thing. Prepared statement. Oh, that is actually hard to read. I apologize to everybody. Prepared statement. Update employees, set name equals question mark, where ID equals question mark. Then below that, you go set string 1 and 2 for new name and ID. Okay? Then you say statement.execute the query. When you send that down to the database is going to look at it, and it is going to pre-construct this entire query and say, this is what it looks like. It's going to take that query and it's going to cache that query in memory. And then, after it's done that, it's going to fill this 2 pieces of data in and then execute it. That means the database already knows where the data is supposed to be and where the control characters are supposed to be, right? So if I set the new name, my new name that I got in from the request, which is a bad idea for input validation. If I set the new name to Robert, apostrophe, close parentheses, semicolon, drop table employees, apostrophe, hyphen, hyphen, right? That user's name in the database is going to be exactly what I said it was going to be, right? Not a problem. So this is another prepared statement. This is actually code that we've seen. It's also not good. Somebody here takes a prepared statement, and then they just make the string inside the prepared statement that they need to do, and they execute it. They're kind of missing the point. Okay. This is an example of not properly parameterizing your queries. So what this person is expecting to happen is what we showed on the previous slide, where the database sees set name, Robert, drop table employees, where ID equals 0. That's what they're, okay? But when they do this with this code, what actually happens is set name equals Robert, semicolon, drop table employees. Guess what? No more database table, hooray. Okay, that's SQL injection. That's what SQL injection looks like in the most ideal closed world, okay? This is a terrible, terrible, terrible attack string. It almost never works. But John Callahan, if he was here, would tell you all about that. In any case, so for those of you who don't know SQL, the semicolon tells them to end the statement. So you're starting a new statement after the semicolon. Hyphen hyphen says comment out and ignore everything that happens after that. So basically what I'm doing is I'm starting a new statement in the SQL database, and I'm telling the SQL interpreter to ignore everything that happens after this. I don't really care what it is. So yeah. So parameterize your queries. Do this, question mark, 1, 2, set strings, all that stuff. It's awesome. I like this. I can't have a presentation about SQL injection without having this comic.
Is it Bobby tables?
It is body tables, yes. A wonderful XKCD. There are constructs in every major language to do prepared statements. Okay? Java, .NET, Ruby, Python, Rails, Grails, Django, PHP, everything. They all have the ability to do this, right? It's all a built-in language construct. So you should use it. You don't have an excuse not to. Okay? So what about ORMs? ORMs, for those of you who don't know, it's a software framework that kind of keeps the software that we write, the business logic, one level away from the database. It lets us deal with language tables, deals with database objects in kind of an abstract way as part of the language rather than something that is, where I'm actually writing SQL queries inside of my code. Most of these technologies, Link is Microsoft's, Hibernate is the dominant one in Java, Active Record for Ruby, Gorm for Grails, the list goes on, right? All of these object relational mapping tools, ORMs, do the work for you, okay? So if you're using an ORM, awesome, keep using it. They're great, okay? There are some problems with Hibernate, right? If you don't use them as designed, you can do custom queries in Hibernate, and you shouldn't do it because it makes you vulnerable to SQL injection, same as if you didn't, same as if you were just doing raw SQL. But if you're using it and you're using them as designed, it takes care of the problem for you. So they're great. Use them if you can. Any questions about parameterized queries?
Do all of the ORMs that you know of, are you able to do custom queries and screw it up?
Not all of them. Link, you're not able to do it.
Entity?
I don't know.
Okay.
I'm not sure. Anybody else? Bueller? All right. So now we're going to move on to data encoding. Really, really, really interesting stuff that makes the world go round, right? Everybody cares about output encoding. No, nobody cares about output encoding, right? It looks different in different languages, and in fact, in Java, there's like a bajillion different ways to do it. But it could look like function escape XML, cout does HTML encoding, server.html does it in .NET. This code nugget, the angle bracket percent sign colon does it in .NET. These are the exact same thing, actually. Mustache does it with 2 of the curly brackets. 3 is bad, 2 is good. So .NET also has one code nugget that is angle bracket percent sign equals. That one does not do output encoding. I don't know why they decided to make them so close to each other, but they did. So this is the one that doesn't have output encoding. Now, the reason why we care about this is if we take an unencoded output and an encoded output, and we have model.data, we put a script tag, a JavaScript script tag, an HTML, inside model.data. When they get rendered to the web page, they'll do this. The unencoded one will just say, new paragraph, script, source, hackers.org, cross-site scripting.javascript, close script. Okay? Whereas if we do the encoded one, it gives us ampersand LT, semicolon, does the HTML encoding for what comes out of that. So why do we care about that? Why do we care about making sure there's no script tags coming into our web pages that we don't intend to have to be there? What can you do with Java? Anything you want, right? If I'm an attacker and I have control over the JavaScript that's executed in your browser, I can make your browser do whatever the hell I want it to do. I can redirect you to a page in Romania and make you download malware. I can send you to a page that impersonates a real login page and have you enter in your credentials. I like credentials, they're awesome, okay? I can do any number of things to the user's browser. If me as an attacker, I control the browser, right? So this attack, this right here, cross-site scripting. This is how it happens, okay? When an attacker can, one way or the other, control what happens in a user's browser. The most common, one of the most common ways that I used to see this, it's less so anymore, but the way I used to see this is when you have an error page, error.aspx, question mark, message equals. Hey, something went wrong. Yay, right? Because then I'd say message equals script. Do something else. Close script, and that JavaScript would get executed. Okay? Where are we? Yep. Okay. So this is what's called HTML encoding, right? We take this value, the angle brackets, and we turn them into ampersand LT semicolons when we're putting it out to an HTML web page, right? It's HTML encoding. A lot of the other things we looked at, the cout tags, the encode XMLs, they do very similar stuff. So what about this with output encoding? We've got a cout tag right here. This is in Java, does HTML encoding. What does this do? Anybody?
It's between script tags.
Yeah. He's got it. Anybody else? So this is already, this does HTML encoding, but this value is already inside of a script tag, right? So the context that the browser is going to be interpreting this in is not HTML, it's JavaScript. Okay, so if we do HTML encoding here, okay, cool. Doesn't really matter that much because I can replace it with JavaScript. I can change the window location with something else and have that JavaScript execute in the user's browser. I don't even need a script tag. It's already there, right? Problem solved. This may actually not be the best example. So those of you editing me on the internet, let me know because that might not be right. That's what happens when you're editing a presentation at 10 o'clock at night. So output encoding needs to be relative to the context that you're outputting to, right? If you're putting data out on an HTML web page, do HTML encoding. If you're putting data out to your URL, do URL encoding. If you're sending something to a JavaScript interpreter, do JavaScript encoding. If you're putting something in an XML file, do XML encoding. Okay? Nodding, always properly encode based on where you're sending the data. You'll solve people a lot of problems that way. There's a whole bunch of options here. We have Java and .NET listed, but there's options all over the place, right? Again, like parameterized queries, prepared statements, parameter, whatever. These exist in all major languages, right? All major templating engines have this. So if you're coding in Ruby on Rails, they've got it. Got Mustache, they've got it. Everything has the ability to do this. Any questions about output encoding before we move on to the next one thing? Okay. Number 3, validating all of your inputs. Remember this? Still something wrong with it. What's wrong? You, I know, you said it.
Not validating the input.
Yeah, we're not validating the inputs, right? You got ahead of us. So when you take information, when you take data into your system, you need to be very aware of where that data is coming from and whether or not you should trust that data source, okay? If you're taking information from over the web, that could be whatever the hell it wants, right? It doesn't have to be even properly formatted because I can, as an attacker, take what's coming out of the browser, intercept it with a local proxy and change it to whatever the hell I want it to do. I can automate it. I can write a Perl script to just blast something out at your website and make it do whatever the hell I want it to do, right? So you shouldn't trust anything that comes in from the web. You shouldn't trust hidden form fields. A number of times I have broken into a site using hidden form fields, I swear, right? Shouldn't trust cookies. You shouldn't trust headers. You shouldn't trust form post parameters. You shouldn't trust query strings, okay? None of that stuff. You shouldn't trust any of it. And you should think really, really, really hard before you trust stuff in your database. I know people hate me when I say that.
No, it's true. That's what happened to Twitter a while back. With,
Yep.
Somebody wrote JavaScript as a tweet, and that was saved to their database,
Yep.
and they served it up to everybody.
Yep. So what if we set new name? So up here, while we're up here and we're getting our data off of the web page, somewhere in the request, we set new name to Jack, script, hackers.org, close script. Our new name is Jack with the script tag in it. And that's cool. It's not SQL injection. We don't care. Right? It goes into our database. It's fine. Hell, we even do output encoding. We're great. When that goes out onto our web page, it's going to be displayed properly. I mean, Jack's going to have a really weird name, but whatever. I don't care. And 6 months down the line, somebody else says, hey, you have really, really great data in that system. We want to integrate with you. We want to pull that data out and use it ourselves in our own application. And they don't do output encoding. Why would they do output encoding? They trust that data. It's your data. And somebody else renders it badly. And now all of a sudden they have cross-site scripting popping up on their page. Yay. Okay? So input validation. You should do it. It's important. And if you're pulling data from a shared database, you should probably think about it. It's not a bad idea. Yeah, cross-site scripting. Hooray. Somebody made a mistake. Okay. So validation. validation is complex. How do we do it? It's pretty simple at the base. If you're expecting something, make sure it's that thing. If you're expecting an ID number and you know it's going to be an integer, store it as an integer. Don't store it as a string. Then I've seen like people have database tables where their member ID or their client ID is stored as a string in the database. I'm just like, what are you doing? Why? Right? There's no reason. So if you're expecting an ID, cast it to a number. If you're expecting a date, cast it to a date time. If you're expecting a Boolean, a true false, a radio button, cast it to a Boolean value, right? There's no reason to store that stuff as strings. It's never going to be a string. And if it's not a string, if it's not true false, someone is messing with you, right? And that's not a good thing. One of the rules that I forgot to mention up here is people try to recover from data validation all the time. Like, oh, they failed our data validation. We should try to clean it up and let this data proceed. No. If something failed your data validation, it shouldn't be coming in the first place. And either the person needs to know about it, or somebody's attacking you, and you should just go, nope, done, kicked out, we're out of here, refused. Another thing, if you have a drop-down list on the website, and you're storing it as a string, that's great. It has to be a string in your database. That's cool. Let's say you have a state list drop-down, Alabama, Arkansas, all the way down, right? Why would you expect, why would you accept a script tag in that? Why would you accept any value other than a US state? You know what it's supposed to be, right? So check it. As that stuff comes in on your web form and your controller or whatever else, just say, hey, is this one of the 50 states plus the District of Columbia? Maybe Guam, generous. Yeah, it is. Okay, cool, let's let it through. No, let's kick it off, it's invalid. So, but what if we're expecting more complex input? What if we have to accept people's first names? Because the website never asks for your name, right? Okay, that's when we need to get a little bit more complicated, and that's where things get a little bit interesting. One way to do it is to use a regular expression or some other way like that to do a whitelist, right? So what this says, this regular expression, this is in a .NET on a name field. It says, if the name is not lowercase a to z, uppercase a to z, any number, spaces, periods, ampersands, apostrophes, hyphens, it's invalid. We don't care. Done. Yeah, it's not one of these. I don't want to store it. It's not a name. Okay? It's called whitelist. The analogy I use for whitelisting versus blacklisting is, like you go to a bar, right? And the bouncer at the club looks at you and says, all right, you're wearing, let's say you're wearing pretty good clothes. You've got a nice suit on, you've got a tie, you've got good shoes, I'm letting you in. That's a whitelist. The bouncer has some specific set of things that he's expecting, or she, and if they don't get what they're expecting, they're going to kick you out. Okay? Now, what is a blacklist? Any takers? Takers, yeah? Yes.
It's a list. It's the opposite. It's a list that's opposite such a number of things.
Yeah, it's the opposite. It's the reverse, right? In the bouncer analogy, it's when I go up to the bar and the bouncer says, you have the wrong shoes on, you have the wrong shirt, you don't have a shirt, you're out. Okay, that's a blacklist. They have some list of things that are explicitly denied, and as long as you don't have those things that are denied, it's going to let you in. Okay? Blacklists can get complicated a little bit. This is a blacklist for SQL injection from a relatively popular IDS. It's not complete. Actually, there are gaps in this. And this is a horrendously complicated regular expression, if any of you are happy with looking at regular expressions. Blacklists are very hard to maintain. They're difficult to manage. So yeah, actually this is a better way to do it. So whitelisting, having something you're expecting, it's much, much, much better when you're doing input validation, right? Only accept what you're expecting, nothing else. Problem is that whitelists occasionally, especially if you have really complex data, they can get really, really complex. If you want to have a fun exercise, go onto the web and look up for a full, valid, regular expression positive check for an email address. It's like longer than that previous slide. It's enormous. It's like you have to scroll down to see it. It's like 40 lines long. It's stupid. All right. They can get really, really, really complicated. Blacklists, they have to be really, really thorough. They have to be really, really well maintained to be useful. How many of you remember MySpace when MySpace like had the worm that went through like 10 years ago? Sammy, yeah. Am I dating myself? A little bit, okay. Sammy happened because MySpace had a blacklist of things that weren't allowed, and somebody found a gap in it and exploited it and got cross-site scripting payloads on every single profile in MySpace, just about. It was just self-propagating. It didn't do any harm, it just like copied itself on the user that viewed it. And all of a sudden, everybody in MySpace had cross-site scripting in their user profile.
No harm when he still went to jail and wasn't allowed to use a computer for 5 years.
Yeah, it wasn't the best idea on the person that wrote it. Problem with the blacklists occasionally are the only option. Okay, occasionally you have to do something, right? You have to try to do something, some type of input validation, and blacklist may be your only option. But really, really think hard before you do them. So the last thing to say about input validation, this is a response redirect. So response redirect request query string from the redirect parameter. This is .NET code for saying take the request thing, the request value out of the query string. So you have page.aspx question mark redirect equals blah. Redirect the user to that page. Okay. Redirects happen. Everybody does them, right? But nobody ever expects redirect to the error page or redirect to something else. But usually when they do a redirect, for example, they know what they want to redirect to, and they're just taking the lazy way out and putting it up in a query string and making it in a place where it's accessible to the user or accessible to an attacker. Known personal information, known business level information, information that's already been submitted in a multi-part form, right? If you as a developer already know what a piece of information is supposed to be, don't put it on a web page and let somebody mess with it, right? Check it, validate it, make sure it's what you're expecting, or just don't put it out there in the first place. My favorite story about this is the very, very, very first application I ever assessed was a multi-part, was a PHP out-of-the-box e-commerce site, right? Install this and you too can be an e-vendor, right? Kind of crappy. They had a 3-stage checkout process. Here are your items, here's your payment, are you sure? Check out. On the second and third of those pages, here's your payment, check out. They had a nice hidden form post field that said cart with a number in it, right? I had two $50 items in my cart. That's fine. I go to the first level of the checkout page, two $50 items, make sure it's okay. Second page, hidden form field, $100 in the cart. Awesome. I wonder what happens if I submit this form and make it 25. Okay. Form gets submitted, and all of a sudden I'm now paying them $25 for $100 worth of stuff. Okay. There was no reason for them to have that information in that form. They knew what my cart was. They had that in the back end. They didn't need to show that to the user. They didn't need to let the user modify that value, right? So pay attention to what you're putting onto the form in the first place. That could save you a lot of trouble. That's it. One-on-one, 3 things. So before we talked about questions, I did want to point out OWASP again. It's awesome. A lot of the data we pulled on this for this presentation was pulled off the OWASP site. Cross-site scripting prevention cheat sheet, OWASP proactive controls. Jim Manico did an awesome job putting those together. OWASP top 10 project, and I double listed the OWASP proactive controls because again I was editing this at about 10:30 last night. So, any questions?
I have a question.
Yeah.
You spoke about IBM app scan.
Yeah.
What tool do you prefer? IBM app scan, Burp Suite? What are you? Can you just
So the question was, for those who couldn't hear, I mentioned IBM Rational App Scan. Are there tools that I use or that I prefer between in that kind of realm of tools and whatever? Yes. I've used most of them. I think it's really a matter of using the right tool for the right job. IBM Rational App Scan, HP Web Inspect are kind of the top tier. They'll find a lot of stuff. They'll take a lot of time. They'll make a lot of noise. Acunetics, NetSpark are a few of the other tools. They're cheaper. They find things. Maybe not as thorough or as noisy as the big ones, but they'll find things. For OWASP Zap project, they're more proxy tools. They're more interceptors and manual testing tools than they are scanners, but they do have scanning functionality. I use all of them. I have used all of them before. If I did nothing else, I would get a OWASP Zap or Burp Suite Professional, just because you can do a number of things with those. They're good tools, and they're usually really cheap. Or OWASP Zap is free. Does that answer your question?
Yeah.
Okay. Any other questions? Yeah.
Quick one. Just do you have any recommendations on some general, other than OWASP? OWASP is a great resource. For
Yeah.
resource. But any other training resources?
Invisium has some great webcasts that they put out for free.
Who's that?
Invisium, N-V-I-S-I-U-M. You can ask Rinaldi about it. It's a local company, and Rinaldi helps run. You would also check out for, let's see, I think there were some security YouTube videos. I can't remember what channel they're on, but there are a number of good resources out there for those. Yeah.
If you want to post something on our Meetup page, there'll be a bunch of folks will be happy to share some of the resources.
Yeah. Sounds great.
Yeah.
That's good. Thank you all very much for your time. This is outstanding stuff.
Yeah.
I had one comment,
Yeah.
if I may. Are you familiar with what it used to be called the software assurance forum? Sorry to be a boring middle-aged government guy.
Yeah.
Retired. but software assurance forum actually, Joe Jarvison's DHS, DOD. Yeah.
They're actually meeting in my room.
That's what I was going to bring up. It's next week, actually.
Okay.
And actually, there's been a OWASP representative speaking there before.
Good.
And it's always good to get that. Because every once in a while, we get a little bit to stay.
We can get, yeah.
And you guys come in and shake it up pretty good.
Sure. So what was the name of it again?
But it's called, it used to be the Software Assurance Forum. It's now called Supply Chain.
Software Assurance Forums.
It's now called the Supply Chain Security. I got
It's through DHS, right? So Joe is employed by DHS and promotes the software security stuff through. And Joe's a big speaker around the OWASP community as well.
Yes, indeed, security completely outward. And it's actually DHS, DOD, now GSA, some other things. Supply chain stuff. It's free. That's a good thing. It's free. That really appeals to me.
I like free.
It's available. It's going on next week at MITRE around Tyson Square.
Okay.
Sorry, didn't mean
No,
to.
thank you.
I'm affiliated with.
I'm going to follow up with you, actually. I'm going to follow up with you after the talk. Any other questions? Okay. Thank you. Appreciate your time.